Hey there. Okay, we've got a problem here with a mirror, okay, a spherical mirror. This one says that a concave mirror has a focal length of 30 centimeters. Where can an object be placed in order to produce a real image that is twice the size of the object? Okay, so this is going to be governed by our lens and mirror equation. That's the one that says 1 over p plus 1 over q equals 1 over f. Okay, we know what f is, that's 30 centimeters. We don't know what p and q are, so let's go ahead and put in what we got. 1 over p plus 1 over q equals 1 over 30 centimeters. Okay, so we don't know the object distance, we don't know the image distance, but we do have some other information here. Okay, we know that we want to produce a real image that is twice the size of the object. Okay, so twice the size of the object, that's going to tell us something about magnification. Now remember, magnification is equal to minus q divided by p. Okay, and the fact that it's twice the size of the object means that m is either going to be plus or minus 2. Okay, in other words, twice the size of the object means m could be 2 or m could be negative 2. Okay? The other thing it tells us is that we have a real image. We want to produce a real image, and this is telling us, remember, that q is positive. All right? Remember that the sign of q tells us whether one of the things that tells us is whether the image is real or virtual. Okay, in this case, q, since the image is real, that means q is going to be positive, p is going to be positive, and so that means that my magnification is going to have to be negative. Okay, and so I know that minus 2 then, that's my magnification, is equal to minus q over p. The minus signs cancel, and I end up with q is equal to 2p. Okay? So I still don't know what q and p are, but I can take this and I can use it over here. So watch. I can go 1 over p plus 1 over, let's see, q is 2p is equal to 1 over 30 centimeters. Okay? And then I can go ahead, now notice the only variable in my equation here is p, so I should be able to solve for that. The way I'm going to solve for that is I'm going to basically put these over a common denominator, which means that if I want to make, essentially I want to make the denominator here 2p. Okay, so if I multiply the numerator and the denominator by 2, I get 2 over 2p, because notice the 2's cancel, I just got 1 over p, plus 1 over 2p is equal to 1 over 30 centimeters. Okay? This means that, let's see, when I multiply these two fractions, they're over a common denominator now, so I just add the numerators together, so I get 3 over 2p is equal to 1 over 30 centimeters. Okay, and then there's a variety of ways that you can solve this. I'm just going to sort of cross multiply here. So 3 times 30 centimeters is equal to 2p times 1. And so p, let's see, this is 90 divided by 2. It's 45 centimeters. Okay, and of course p is the object distance, so that's telling me how far I have to place the object in front of the mirror, all right, which is exactly what I wanted to find here. So in other words, the answer is I want to place my object 45 centimeters in front of the mirror. That's it.